Live from Twinsburg, it's Algebra 1! Quadratic Functions, Day 1. All right, this is our last real function that we're going to talk about. So far we talked about linear functions, exponential functions, and now today, quadratic functions. So we've already talked a little bit about this, so hopefully a little bit of this will be a review. Here we go. All right, the objective. Identify quadratic functions and determine whether they have a maximum or a minimum, and graph quadratic functions and give its domain and range. Vocabulary: quadratic function, parabola, vertex, minimum, maximum, and we're going to see a few other words too. However, these are going to be the heavy hitters for today. First one is the standard form of a quadratic equation. So if you look here, we have our quadratic equation here. This is in standard form. So again, y equals, those are the magical words of Algebra 1. This ax squared term, right? Because if you look from what we did with polynomials, if we put those vertical lines in front of our terms, remember what's a term? Excuse me, what's a term? Somebody, what's a term? Good, finally, someone. Sign, number, letter. Again, A, B, and C are coefficients, or for C, it's a constant. But again, remember, a term is a sign, a number, and a letter. So what we're going to call this first term, that ax squared term, is the quadratic term. Anything with that as the highest degree is going to give you a quadratic function. Bx. The bx is going to be the linear term. Again, I know I'm annoying. I'm a little brother. Linear term or linear term gets you a straight line. And then c is going to be the constant. Anytime we have that constant, if you recall, it's always the what? That y-intercept, all right? So again, the highest exponent is 2 for a quadratic function. Therefore, the degree is 2. That's why we call it a quadratic term. So there could potentially be up to 3 parts. The one part that you need to have is this term, the x squared term, all right? If we don't have the x squared term, it's either linear or it's just a constant. So you pick. All right, so if you look here, just identifying what's going on here, we have, here is our quadratic function in standard form because you have your what? Ax squared first, your linear term next, and then your constant term. So here again, we have our quadratic term is 5x squared, your linear term is negative 7x, and your constant term is 1. Any questions? All right, if you look, you can see that I have 3 up here. So let's shrink that one. Let's make this one the large one. Here, if you notice, what's missing? We only have 2 terms. What term has to be there? Of course, the quadratic term, which is the 4x squared. Some of us might get confused and say this is the linear because linear comes next, but what does the linear term have? In parentheses down here, I'm just going to put the x. It has an x. That we don't have an x term, so we have 0 linear terms, and then that constant is negative 3. All right? So again, give me some time to erase. My apologies. I'm going to shrink this graph here. Oops. Put that bad boy over here. And now, let's try this problem. The quadratic term. So again, we have 3 terms here, so we know if the lead coefficient or the lead term has the x squared, that's the quadratic. So this is in standard form, x squared, x, and then no x. So our quadratic term is the 5x squared. Our linear term is just the x term. Again, don't forget the sign. That sign is already bundled up. Again, seeing how this is the holiday season, we have little bows that we can put on top of each term too, right? So you can see that we have 3 presents that the Amazon truck dropped off. Of course, the Amazon truck comes all the time because my wife loves Amazon. And then our constant term is 3. So you have 1, 2, 3 presents if you want to think of it that way as well. Which present means the most to you is normally going to be the biggest present. So that's going to be the biggest degree, our x squared. then we have our middle present, and then the last present. So normally if you're going to start giving a present, you normally give like the weakest one first, and then you save the end for last, right? The best one for last, so that would be the quadratic term. All right, just to keep it in quadratic form. Identifying quadratics from a table. So there's really three ways that we're going to talk about this. We have a table, we obviously have equations down here, and then a graph. The graph, we have our best friend Desmos here. I just gave you a sneak peek. My apologies. I didn't want to show you that. Hold on. Oh, there it was again. All right. So let's go with, how do you get it from a table? How do you know if it's a quadratic function? So the reason why I like to bring this up, quadratic is x squared. So what we are looking for, and this is kind of where I was talking about with the reminder part. We did this when we talked about functions. We looked for a second common difference. So what I'm going to do is just say, how do you go from -9 to -2? Right? We added 7. How do you go from -2 to -1? You added 1. How'd you go from -1 to 0? We added 1. How'd you go from 0 to 7? You added 7. So right off the bat, it doesn't look like we have a common difference, which we don't have a common difference. However, the next thing we need to do is find what is my exponent? 2. We need to find the second common difference. So that first hump was the first change of adding and subtracting. We just talked exponential prior to this. That was multiplying, remember? Linear was adding, so this is going to be adding again. It's just to the exponent of 2, which means the second degree. How'd you go from 7 to 1? What do we do? We subtracted 6. How'd you go from 1 to 1? There was no change. And then how'd you go from 1 to 7? You're back adding 6. Do you see a second common difference here? Are these all the numbers that we see common? -6, 0, and 6. No, so guess what? This is not a quadratic. So I'm just going to put not a quad. All right, let's see if the next example is. How'd you go from 4 to 1? We subtracted 3. How'd you go from 1 to 0? We subtracted 1. How do we go from 0 to 1? We added 1. How'd you go from 1 to 3? We added 3. All right, so now let's go from -3 to -1. What'd you do? So our second difference, because remember our exponent's a 2, we did what? How'd you go from -3 to -1? We added 2. How'd you go from -1 to 1? We added 2. How'd you go from 1 to 3? We added 2. So now we're going to circle that second hump that we just did and say, is this a second common difference? Do these have the same number in common? So you can see 2, 2, 2. So this example would be yes. And again, as teachers, we're going to show you an example that works normally, an example that doesn't work, all right? Just because we want to show you both ways. All right, so now let's look at an equation. So these were tables, obviously. These next 3 examples are going to be equations. What are we looking for the equation? Very simple. We are looking for this term up here again, an x squared term. The only thing we need to make sure is that it's in standard form. All right, so it needs to say y equals, what's my highest degree? Here. When my highest degree is 2, we know it's a quadratic. Is this in standard form? 2, 1, and 0. We ordered them by degree. It was already in order. Good for us. So yes, the highest degree here is a 2, so this is a quad function. Here, how many terms are there? It's in standard form. It says y equals. It says 2x minus 4. So that's actually a linear equation. So it can't be linear and quadratic because we're going to show you that in a second, what a quadratic looks like. But this we know is a line function. So we can even be fancy and tell you what the answer is. But that's definitely not a quadratic function. Here we have 3 terms. What's going on here? We have that exponent. The x is our exponent there, so that's going to be an exponential function. And we know that an exponential function is just a curve, like an L-shaped curve. And that's exponential and not quadratic. So this, again, is not quadratic. So again, we're looking for that x squared term being our highest degree. Any questions? Again, pause, rewind it, and re-listen. All right, parabola. You've probably heard this word before. I know with coaching, I do help people who are at the middle school, and parabola is one of the words that I know Mr. Edwards does his little parabola dance to. So with that being said, parabola is the shape, right? That U-shaped function or line. I don't know, it's not really a line. That U-shaped line, sure. And then this other part that they're going to talk about is the axis of symmetry or the line of symmetry. That symmetry is a vertical line that splits the parabola in half, so it's symmetrical. If you fold it hot dog style here, if you fold it on this side, it's going to come back on this side, right? So it's going to be symmetrical. With that being said, all right, so now I'm back at it. So that was parabola. If we look here, determine whether the parabola opens up or down. So the way to do this is just put arrows on the end of these. That obviously is going up, and that's going to be a low point here. And then if you look here, these arrows would point down. So that means it's pointing down. This is a real quick trick to do. One, you could either graph it using Desmos, or when we look at what's given here, what are given here in these 6 examples are the equations. So what we're looking for is when A is positive, it opens up. And when A is negative, it opens down. So when we put it in standard form, remember, ax squared plus bx plus c, right? We could put our y equals over here. A is going to be the what? What's that word called? Oh, close. I thought I heard it. What was it? Coefficient. Good. It's the coefficient for that quadratic term, that x squared term. So again, don't forget to put it in SF. What does SF stand for? Standard form. So if I look here, is this in standard form? Bada bing, bada boom, it is. So this A value is 3. Is 3 positive or negative? It's positive, so this is going to be pointing up. And by up, it has those arrows going up, right? So this is up. B, is this in standard form? X squared plus 4x minus 1, yep. What's x squared's coefficient is 1, so that's positive, so that's also going up. Here, it says y equals first term, second term, third term in order, second degree, first degree, no degree. What is my coefficient for A, or the x squared, is negative 1, so that means it's going down because it's negative. Here, I'm missing a term. What term am I missing? I have the quadratic term there, so I know it's going to be a parabola, and I have my constant, so I'm missing my linear term. No big deal. That just shifts the graph a little bit. All right, so what's my A value for my x squared is just 8. So is that, or negative 8, is that positive or negative? Obviously, I just said negative, so that's going to be pointing downward like this one up here. Is this in standard form? I have 3 terms. What's first? My linear terms first, so be careful. I'm going to have to rearrange these two. So I'm going to get 7x squared first. Do I care about the linear term or the constant term? No, it's all about that A term. So what is my A term here? Positive 7, so that points up. So this is kind of a tricky one because remember, we got to put it in standard form first. Last but not least, we have 3 terms. It's actually in the opposite order of what we need it in. It goes least to greatest as far as degree, constant, linear, quadratic. That's why we kind of went over the terminology at that first slide. So it's negative 1 again. So again, we had negative 1 right above it, so that's going to be pointing downward. All right, so it's all about that a value. What's the a value? It's the coefficient for the x squared or that quadratic term. Pretty simple, very visual. When in doubt, go to Desmos if you need to, all right? Because it takes time if you don't know what you're looking for, but always use Desmos. This topic specifically is going to be very Desmos friendly, and it should become your best friend if it hasn't already. All right, so we have a couple options of what the answers are. All right, if we talk linear functions, we always talk about the y-intercept. The y-intercept doesn't really matter too much for these. It gives us a free point, maybe 2 free points. However, what we're really going to be paying attention to is that word in the bottom right here, the x-intercepts. What is the x-intercept? Where it crosses the x-axis. So if you look here, I also said words that mean the same thing. You're going to hear zeros. You're going to hear roots. You're going to hear solutions. You're going to hear x-intercepts. So those 4 things are synonymous with the answer for quadratic functions. Remember when we talked about domain and range, you had input, output, independent variable, dependent variable, x, f of x, right? We have all these different ways to say the exact same thing. It's the same thing going on here. Find the zeros, find the roots, find the solutions, find the intercepts. It's the same thing. What we have that's kind of special though is before we only really had one y-intercept. Here we can have up to what? 2 x-intercepts where it comes into contact with the x-axis. That's why we're calling it the x-intercept. So we have this very special point that we're going to call the vertex when it has 1 intercept. This is not very common, right? Because there's one tiny point of this whole parabola that can touch. Here we have 2 arms of the parabola, right? So here's this person, right? There's its arms. The arms are touching here and here. So this is probably the most often what we're going to see as far as algebra 1 stuff. This is the least common, the 1. And then the second common is going to be 0 intercepts. What do you notice happens with this parabola? It doesn't come into contact with the x-axis. So that's why we say it has 0 solutions or 0 roots or 0 zeros. All right. So it's either 2 solutions, 1 solution, or no solutions. Another way to say it. Again, zeros, roots, solutions, x-intercepts, words that mean the same thing. This kind of just goes to show you what this equation would look like. I would use Desmos for this, but how many answers does it have? It has 2 x-intercepts, right? So this means go left 1, don't go up or down. It means go 2 to the right, don't go up or down. You see why they're called zeros? Because when we write them as ordered pairs, we have zeros for our y's, all right? Here, this equation looks like that on the graph. This is that special point, that highest point for this part here, or the vertex. So we have what? 1, 0, because we shifted it 1 to the right. Again, they call them zeros because they always have y equals the 0, or the 0 is always equal to y. Last but not least, we only have 2 terms here, but of course we need that quadratic, or else it wouldn't have that little smiley right there, known as the parabola. How many times does it touch the x-axis? 0, so this is no solutions, or 0 solutions. All right, so again, very visual stuff. When it comes to visual, go to Desmos. Here is the vocab word. The blank is the highest or lowest point of the parabola. I said on the last slide, it's a very special word. It's going to give us a lot of information. It's called the vertex. The vertex is the highest or lowest point. If you recall, we had the highest point or the lowest point was when we were pointing up or pointing down. All right. If the parabola opens up, that means the arrows are pointing up. Is this the highest or lowest point right down here? Right, you see where I'm at right here? Is that the highest or lowest point of that roller coaster? It's the lowest point. We call the lowest point the minimum, all right? So if your arrows point up, that means your vertex is all the way at the bottom, all right? So that's going to be a minimum, all right? So again, I can draw that one over here. Since these are pointing up, this is the lowest point. That's going to be my minimum. And then if I go over here, if the parabola opens up downward, they're pointing downward. That means this is like the top thrill dragster. This is the highest point. That sometimes it makes it over, sometimes it doesn't. I'm very jealous because I had a season pass this summer, but we did not go because of the whole COVID deal. So this max point is the highest point. All right, and I can draw that over here too. That's the highest point. That's called the maximum. Another word for this is going to be called extreme values. The vertex is always where that parabola goes up and then comes back down. So this is going up and then comes back down. Or if you're going left to right, where it comes from down and then starts to shoot upward. So again, this A value is positive because it's pointing up. This parabola would be negative A because it's pointing down. What is this vertex called? The highest point is the maximum point. This lowest point down here would be my minimum. Another word that the state likes to use are extreme values or the extreme value. That would also be the maximum is the high extreme. And then over here in that pink parabola, that would be the extreme value, that is the minimum value. So the lowest point versus the highest point. Another vocab term is that axis of symmetry. The axis of symmetry is that vertical line, which we know is not a function, right? Because every function normally starts with what letter? Y equals. But here, we know that this vertical line right here is not a function, right? So this isn't going to be y equals. It's going to be what letter? What's the opposite of y? So these are always going to be x equals. Whatever the x value of the vertex is will be your AOS, your axis of symmetry. Again, it's always going to be x equals because it is a vertical line, so we need to call it x equals, and that x is going to be coming from your xy of your vertex. All right, just a quick, what way are these arrows pointing? Up. So this would be a minimum, and our A value would be positive because the arrows are pointing up. Here, this is a maximum, right? So this one over here was a minimum. This up here is a maximum because our arrows are pointing down, which means that our A value is negative. So there's a lot of vocab, a lot of cheat things to help us out with this, all right? Almost there, 14 out of 18. I know it's a lot. So ready? For each parabola, identify the vertex. Give the minimum or maximum value of the function, and then find the domain and range. So ready? Domain and range means the x values and the y values. All right, so ready? Here's the highest point. How do I call it the highest point? Because it's the highest point. If I go left to right to left, doesn't matter. Identify the vertex. What is that vertex? So what's the x value of that point? We went 1, 2 to the left, so that's -2, and we shoot all the way up to 6. So there's my vertex. Is that a max or a min? That's the highest point. So that extreme value is the maximum. And then the domain is the x values, remember that. And the range are the y values. So because these have arrows on them, they're going to go on forever. So your domain is going to be all reals because as this gets wider and wider, these parabolas just keep getting wider and wider as well. What is your range? Your range is going to be anything below what value? 6. So y is less than or equal to 6. Because if I draw that horizontal line here, your parabola is below, so that means less than, and it reaches that maximum point, so it's equal to. What's your y value? 6. So you can see where this 6 is coming from your vertex, all right? Let's check out our other example. So here we have our arrows pointing up, so we know our A value is positive. This is going to be my minimum value. I'm going out of order. I know, that's okay. What is my vertex? It's always an ordered pair. We always start at what? The origin and go left to right first. So we went right 1, 2, 3. And then we went down to -3. All right. Domain, because there's arrows, this is just going to keep getting wider and wider as it gets bigger and bigger. Or as we zoom out, I guess. So our domain is always all real numbers. And then our range is going to be that y, because range is the y value. And if we draw right from that vertex, this is above, so it's going to be greater than or equal to, what's my y value of a vertex? -3. All right. Again, if this is too fast, you have the luxury of slowing it down, rewinding it, replaying it as many times as you want. All right, this is one of the last topics. This is the vertex form. It looks weird, all right, but I can promise you, what do you see here? You see that x squared. So anytime we see that x squared, it's probably going to make a what? A parabola. So the first slide we talked about was standard form, ax squared plus bx plus c. But this is also an equation because obviously we have an equation here. But this is vertex form because this is your x value of the vertex. It's just going to be the opposite value because that's what a negative means, is the opposite. And this is my k value, which is my y of the vertex. That's why they call it vertex form, because this is your x opposite of your x value, and this is your c value, or your y value for your vertex. Sorry. A tells you whether it's open or down. So if this is positive, it's going to go up. If it's negative, it's going to go down, which also tells you if it's a maximum or minimum. Because remember, if it points up, it's a minimum. If it points down, it's a maximum. So it's kind of backwards from what we normally think. H gives you the axis of symmetry. So x equals h. H is in front of that negative. And then gives you the vertex or tip of the parabola. All right. So HK is really the xy of the vertex of the parabola. All right, so the graph of the function is in the form f of x equals a parentheses x minus h squared plus k. So again, this is called vertex form because what's the most important point besides my solutions is going to be my vertex. So I can tell you right now, my a value is doing what? Right, it's pointing downward. All right, so I know this is a maximum. What's my vertex? So I'm just going to rewrite f of x equals a parentheses x minus squared plus k. What is this vertex? I go from 0 over 1, 2, 3, so it's 3. Up 1, 2, 3, 4, so it's 3 comma 4 is my vertex. So again, if you remember from this slide, my h is going to be my x value and my k is going to be my y value. So when I plug this in, it's 3, which means it's going to be the opposite of 3 because we're going to distribute that negative to it. And then I have my 4 over here. So now I get f of x equals a parentheses x minus 3. Remember, this is the opposite inside because of that negative. That's always there. Plus 4. Don't forget your square. Now, what are we missing here? We don't know this a value. We don't know the f of x. We don't know the x. We do know the vertex. So what we need to do is pick a point. I'm going to pick this point right here. It looks easily plottable to get the a value because my x for this point is 2 and my height is 3. So what I'm going to do is substitute in. Remember from way back when, f of x really equals what letter? Y. So this is the y I'm going to plug in is 3 because it's part of that function. I don't know a. I do know my x is this 2 right here. And then my -3 plus 4 is going to stay. Now I'm going to simplify. What is 2 minus 3? -1 squared plus 4. I still have times a out front equals 3. Well, what's -1 times -1? That's going to be a times 1 plus 4 equals 3. What's 1 times a? I'm just going to bring my work over here because I'm running out of room. 3 equals 1 times a plus 4. How do I get this 4 to go to the other side? Because I'm solving for a. So I'm going to get a equals -1. Because whatever I do to the right side, I do to the left side. So this simplifies that out to get its crossover to the other side. That 1, you could divide by 1, but why do that? So if I rewrite this function in vertex form, I have it up here already. Now I can put my a in. So f of x equals -1. So we knew it was going to point down, so this should be negative. Remember, because these arrows are pointing down. So I got my a value. I keep my x, my negative, put my 3 in, square it, plus 4. So I rewrote that based off of this vertex, and I chose a point that was on there. I could have chosen this point, I could have chosen this point, or I could have chosen this point. So there's 5 good points that I could have chosen from to rewrite it in vertex form. Again, this seems a little bit intimidating, but remember, we need it to be squared because we need our degree to be 2, all right? And then all you have to do is plug in what they give you, and it's called vertex form for a reason because your opposite of x goes here and your y goes there. Again, my vertex was a 3 for my x term, so that's why you're getting a -3 inside. Last but not least, graph the equation y equals x squared minus 4x plus 3. So this is in standard form. If we recognize my quadratic term is 1x squared, my linear term is -4x, and my constant is plus 3. You must plot 5 points, including the roots of the vertex. If you are plotting points and graphing, if you haven't been if you've been living under a rock, hello, Desmos, I've already plugged this in. X squared minus 4x plus 3 to just save time. There you have silver balls, silver balls. All right. What are those? 4 points. I can plot those 4 points, right? And then what's another point to plot? This one right here. If I look at it, I can stop maybe. There it is, 4, 3. So I have these points. I'm going to unhighlight them real quick just to talk about those points. One of the most important points that you can possibly find is going to be that vertex. So 2, -1 is my vertex. Now, is that a maximum or a minimum? This parabola is pointing upward. So this is the lowest part of the roller coaster hill. So this is going to be the minimum. If you look, the other thing I can say is this is the axis of symmetry, is where this is going to cut it in half, is a vertical line, and I don't know if I can really write on this, is a vertical line that splits the parabola in half, so that's going to be x equals 2 to bring back that terminology. What is this little fellow over here? That's the y-intercept. The y-intercept is just a free point, all right? And you can say, hey, how far did you go from the vertex? I went 1, 2 to the left and up 1, 2, 3, 4. That's how I got 0, 3 for my y-intercept. So if I go 1, 2 to the right, and then up 1, 2, 3, 4, because of the symmetry, I can either just graph it by tracing it and seeing 4, 3. So I can just go to Desmos or go to Delta Math and plot those points there. And then the last thing I want to pay attention to, again, we want vertex here, we want y-intercept, so I'm going to unhighlight those. How many solutions or roots does this equation have? 1, 2 solutions where it touches the x-axis is 1, 0 and 3, 0. All right, so when it asks for 5 points, these 4 points are going to be huge for your success, and you didn't really have to do anything. You have to make sure that you type it in correctly into Desmos, and then Desmos will actually tell you and highlight those points for you. So when we say Desmos does everything for you, we really truly mean Desmos does everything for you. We just need to recognize. So again, when we go to plot these, all you have to do is plot those points into your Delta Math. So obviously you can see this is a Delta Math question, so I wanted to give an example of that. Desmos is going to be your best friend. Last but not least, my favorite slide is the last slide, which is just to reiterate today's quadratic functions. If we go all the way back to the beginning, let's make sure that we have the objectives, identifying quadratic functions, determine whether they have a maximum or minimum, quadratic functions, domain and range. You can go back to that slide. Quadratic function, ax squared plus bx plus c is standard form, right? We also talked vertex form. Parabola is the shape. Vertex is the highest or lowest point, the highest point being the maximum, the lowest point being the minimum. Minimum, A is positive. Maximum, A is negative. Boom, boom. Those two words right there. Other than that, if you like what you see, if you like what you heard, give me that thumbs up. Hit that subscribe button. And as always, I gotta be quiet because my kids are sleeping. Here we go, brownies. Here